Giddings & Lewis is proud to introduce the Variax Vertical Machining Center. The pioneering technology represented by this breakthrough machine tool demonstrates that Giddings & Lewis continues to be the manufacturing technology leader. Machine tool design evolved based on the concept of a man moving a machine along straight lines. On this simple milling machine, we see a set of perpendicular ways. On conventional machine tools, ways must be perfectly straight, parallel, and orthogonal in order to achieve the accuracy required by today's manufacturers. This perfection is difficult to achieve. Looking beyond the conventional and imagining the possibilities led us to the revolutionary new technology of Variax, the first fundamental change in machine tool design this century. Imagine a spindle floating in space, unrestricted by the constraints of orthogonal design. It was this initial thought that guided the designers of the Variax Machining Center in their search for a better way to make a machining center. Variax has attributes unattainable in conventional machine tools: unprecedented speed, acceleration, rigidity, and dexterity, all in one package. The basic components of Variax are a lower platform which contains the pallet, an upper platform which houses the spindle and tool, and the 6 legs and servo motors which move the upper platform. A fundamental and important departure from the traditional is the concept that the Variax machine is the structure. Unlike conventional machine tools, there is no separate supporting structure. To machine a part, we change the shape of the Variax structure itself. Changing the shape of the Variax structure is accomplished by extending or retracting the 6 legs which move the upper platform. Within the legs are 6 ball screws driven by individual servo motors. By operating simultaneously, the 6 servo motors contribute to the incredible thrust of Variax. It achieves greater than 7,000 pounds of continuous thrust. Most of the components in the Variax Machining Center, including the ball screws and servo motors, are standard field-proven parts, making this machine very reliable and easily maintained. Gimbals connect the legs to the upper and lower platform. Each gimbal allows 2 axes of rotary motion, thereby preventing any bending moment from transferring to the legs. Like a truss, the forces are either in tension or compression. The axis coordinate system is identical to a conventional machining center. X is side to side. Y is forward and back. Z is up and down. The rotary axes rotate about the tool tip. A rotates about the linear x-axis. B rotates about the linear y-axis. C rotates about the linear z-axis. Embedded control software commands the leg motions required to move the spindle in these axes. These are transparent to the operator, who uses conventional machine tool part programs and programming language. On a conventional machine, axes are determined by the orthogonal machine members. On Variax, the axes are virtual. They are mathematical rather than physical. A field-proven laser interferometer device is used to precisely establish the length of each leg in real time. This laser feedback permits accurate positioning of the spindle with respect to the part in the full 6-dimensional space. Variax maintains active control over all 6 degrees of freedom: XYZ, pitch, roll, and yaw. The resulting 6-axis contouring and positioning capabilities make Variax a natural to machine parts with complex geometries, contours, and thin wall sections. Variax greatly simplifies fixturing and part setup. Normally, a part is positioned to the machine geometry. Variax uses its mathematically aligned virtual axes to adjust itself to the part. Fixture precision and part location are no longer a manufacturing obstacle. Reducing the number of setups and machining at the impressive speeds of the Variax Machining Center will produce profitable results. On a conventional machine, machining this part normally requires more than 19 hours to set up and complete. On Variax, this is reduced to 3.5 hours, more than a 5 times improvement in throughput and productivity. This machine is the Variax prototype. We began cutting metal with it in 1991. The production model, available in early 1995, has an even more futuristic look. The space frame design gives Variax an inherently distinctive appearance. The design of this space frame and the legs draws on a very basic physical principle. The triangle is the strongest geometric structure. The triangulation of the crossed legs contributes to the impressive rigidity of this machine. Variax has 5 times the rigidity of a conventional machine. A new level of manufacturing precision is one of the benefits of a machine this rigid. Variax accuracy is measured volumetrically, the same way parts are measured on a coordinate measuring machine. The accuracy of Variax is on par with CMM accuracy. At 2 to 10 times the accuracy of a conventional machine tool, Variax will change the way manufacturers view machine accuracies. Since the rigidity of Variax is derived from the machine's geometry and because the machine is structurally self-contained, no foundation is required. In an age of agile manufacturing, the ability to easily relocate Variax will enhance the flexibility of your manufacturing facility. Variax is 5 to 10 times faster than a conventional machining center. The speed of this Z-axis move is 2,400 inches per minute. The Variax production model is capable of contouring at speeds in excess of 2,600 inches per minute. That's not a traverse rate, that's contouring. Acceleration of greater than 1 G also puts this machine in a class by itself. With this incredible speed and acceleration, the spindle isn't the only part of the machine that moves. Isolation pads act as shock absorbers and isolate the machine from the shop floor. The highly damped compliant mounts lead to improvements in key machining performance parameters. Vibration, damping, improved accuracy, and increased dynamic stiffness are all benefits of these floor mounts. A space frame platform gives the structure rigidity without adding mass. The structure was optimized through extensive finite element analysis. The Variax Machining Center's unique structure requires an equally innovative tool exchange mechanism. Giddings & Lewis engineers designed a tool change arm based on a 4-bar linkage. The tool change arm is kinematically locked to the correct tool delivery path. This uncomplicated mechanism has minimal parts, making it a highly reliable device. One of the Variax design objectives was easy integration with standard peripheral equipment. A conventional, commercially available mechanism is used for tool storage. The same philosophy holds for pallet exchange. A conventional 630 mm machining center pallet interfaces to standard pallet transports. This allows seamless integration into a manufacturing cell or system. The conventional and unique have been combined to bring you the ultimate in machining solutions, Variax. There are machines on the market that are fast. There are machines that are rigid. There are extremely accurate machine tools. Until Variax, never before have we seen the combined power of all these attributes in the same machine tool. Rigidity 5 times greater than conventional. Contouring speed and acceleration 5 to 10 times faster than traditional. Volumetric accuracy 2 to 10 times better than standard. It is this combination of capabilities that is the hallmark of Variax. Giddings & Lewis, the technology leader, invites you to join us in this history-making effort to change the future of manufacturing. Variax.